So for our second lesson, we're going to skip section 1.2 because it's just a lot of geometry stuff reviewed. If you want to look through it, once you get your book, you can, but you won't be tested on anything on it. So it just goes a little deeper with the geometry review. We're going to start with section 1.3, which is your first introduction to trigonometric functions. So you'll learn what they are and what they mean, and we'll start learning how to find them. In order to understand trig functions, we're going to start with this diagram. And basically, for the beginning of trig, we're not going to be working inside of a triangle. We're going to be working out in what we call the coordinate plane. I'm going to give you a point, like maybe 1, 3, or in this case, it's over in quadrant 2. So I'm going to give you an xy point. So maybe that's -2, 5, I don't know. And what you're going to do is you're going to diagram that point. It doesn't have to be perfect, but you're going to make sure you kind of get it about in the right quadrant. You're going to diagram that point kind of as here. So if we put that point out here at the x, y, and you are going to draw a right triangle down to the x-axis. So you go to the closest x-axis perpendicularly, and that forms a right triangle. So even though we're talking about this angle here of rotation, where the theta is here, even though we're talking about this angle, that's your theta, because the trig function involves an angle, we can talk about it with regard to this triangle that is trapped on the x-axis. So that's what your drawing is going to look like, okay? This side of the triangle right here is going to have the same length as the y value of that point. Does y'all understand that? Because to get to that point, I go over here, so this is going to be your x value, and up here, and that's going to be your y value. And then you're going to use the Pythagorean theorem to find the hypotenuse. Does that make sense? So your book says to memorize, and they call it r. They don't call it c like you do in the Pythagorean theorem. They call it r. And the reason they call it that is if you imagine rotating a point around like that to this position, it's the radius of your circle is what it is. So they call it r, but it really is the same as a, b, c. So a squared plus b squared equals c squared, which means that x squared plus y squared equals r squared. Make sense? Okay, so that's how we're gonna start. We're kind of build. So if you're given an ordered pair and you're asked to do something trigonometric with it, you draw that diagram and that triangle. Now be cautious. Never take it and draw to the y-axis. X is called our reference axis in trig, and so you will always go to the x-axis. It will never be with respect to the y-axis. So you won't have your triangle trapped to here. It'll always be trapped to either here or down on this side, on the x-axis.
Will it ever go up?
It can go up. We'll do some of each. We'll do some in every quadrant today, so it'll start to make sense. Then you label the triangle that you have drawn. So you label the x, you label the y, you label the r, the hypotenuse. And you can find that missing r by using the Pythagorean theorem. X squared plus y squared has to equal r squared. Now what's going to bother you about the beginning of trig is this. A triangle technically cannot have a negative side length, but you'll be allowed to use negative to indicate direction. So the x's and the y's will have negatives sometimes. So unlike any triangle you've ever seen, and that would be the case here because it's over here in quadrant 2. So the x value would be negative. So this side length would be represented with a negative number. Don't let that bother you. But you need to make a note of that x and y can be negative even though they're in a triangle.
Because it'll go out when you...
Right. Yeah, it will go away when you square it, so it's not a big deal. But here's the other thing you need to understand. R must be positive for the duration of trig. So that's never an issue. If you're looking for R, you know it has to be positive. So at this point, we want an introduction to what the trig functions are. Okay? A trig function is a function of an angle. Okay? So if I say in this instance, sine of theta, that means sine of an angle. And a trig function is always equal to a ratio of two sides of that triangle that you see when it's trapped there. And now, by itself, trig functions don't mean much of anything. But what we can use them for is we can use them to solve for unknown distances. And so that's what we use them for the most. So if we have an unknown distance, if we know one side, we can use a trig function to find the other side. That doesn't come until, chapter 2. But we are going somewhere with it. Eventually they will mean something and we can use them to do something. But for now, we just want to know what they mean. So what's a trig function? It is a ratio of two sides of a triangle, and it's always, each trig function has its own ratio, and you have to memorize it. So here are the 6 trig functions. This one is called sine, and that is actually spelled S-I-N-E. You should remember it from geometry, but we abbreviated S-I-N. So when we see it, it's not sin of theta, it's sine of theta, and that's how it's read. The of isn't written, but you just know that it's there. So this says sine of theta always equals the y value of your triangle divided by the r value of your triangle. Cosine of theta always equals the x value of your triangle divided by the r value of your triangle. And remember, those are just lengths. They're just numbers. Tangent of theta always equals the y value divided by the x value. And those are your 3 what we call primary trig functions. You should probably remember those from geometry. I don't know if you learned SOHCAHTOA or Oscar had a heap of apples, however you learned it. So when you're not in the xy plane, you can still use SOHCAHTOA for a right triangle. But you can't, in the xy plane, like it's a little harder to see because the angle is not inside the triangle and all that. So it's easier if you know the whole x, y, r stuff. So you need to memorize these. Those are your first 3. These other 3 down here, so this is sine, cosine, tangent. Okay? These 3 down here are their reciprocals. Notice that this one is y over r, but this one is r over y. So if you learn the first 3, you can know and then you can figure out which one to associate it with. You don't technically have to memorize the last 3. So cosecant is this guy's name, and that's spelled C-O-S-E-C-A-N-T, cosecant. Cosecant of theta is equal to r over y. He's the reciprocal of sine. This is secant of theta, and that's the reciprocal of cosine. So his value is always r divided by x, and this is cotangent of theta, and that always equals x divided by y in your triangle situation that you have drawn. Any questions about those? Does anyone know what the units are for the answer to a trig function? Units. Like an angle, its units is degrees, right? Okay. What are the units when you get the answer to a trig function? Does anyone know?
Units.
What's the definition of a trig function? A trig function is a ratio of 2 sides of a right triangle, right? Okay. There are no units because ratios are unitless. So if you're answering a trig function, you won't have any units. It'll just be a number, 2/5, 3/4, -1/2. Okay. So as I said, it's really, really important that you memorize those 6 definitions of the trig functions. And we'll be using that a lot today, so that'll help the memory process get started. For our first example, we're given that the terminal side of an angle, we're going to call it theta, that is in standard position passes through the point 8, 15. Using that, we want to find the values of the 6 trig functions of that angle. First thing we want to do is we want to go draw the picture. We want to draw that diagram that we talked about. So we'll come over here. We'll make an XY coordinate system. And we'll label the point 8, 15. Now it doesn't have to be perfect, just kind of get it ballpark. So that would be +8 and +15. So somewhere out there is that point. Then you extend the ray from the origin through that point. And from there, you construct a triangle. And the triangle does not go to the y-axis, it goes to the x-axis, and it always needs to be perpendicular. So we'll draw it this way. And the angle is always between the positive x-axis and wherever you stopped. So this angle right here, that is theta. Okay? Then you label the sides of the triangle, and you get that from your ordered pair. If this is the point 8, 15, how much is this distance here? That's positive 8, and this is positive 15. So those are the legs of your triangle. And the next thing you need to do is you need to complete that triangle. So we need to use the Pythagorean theorem to solve for this value, and that's called your R value. So we need to go find the R value. So we know that 8 squared plus 15 squared has to equal R squared, because that's a right triangle. So that's your Pythagorean theorem there. X squared plus Y squared always equals R squared. So now we're going to solve that for R.
17.
Okay, so we've got 64 plus 225 equals R squared. And together that makes 289. We take the square root of both sides. And we actually get plus or minus 17.
Yeah.
But we know that with trig triangles, the hypotenuse is always going to be assumed positive, you know, even if some of the legs are in a negative direction. So that's going to be positive 17. Okay. So now you've solved the triangle, so you can go ahead and label it. So tell me again, what's the x value for this triangle? 8. What's the y value?
15.
What's the r value? 17. Those are the only 3 things that you have to figure out. Once you know that, you can start finding the trig ratios. So we're just going to write the definitions up here, and then we're going to answer the questions. We know that sine of the angle in question always equals what? Y divided by r. So y divided by r, which in this case is 15 over 17. When possible, a trig function is always given as a fraction in lowest form. So you do reduce it, you always reduce. Okay, so there's our first answer. All right, we have 5 more to go.
Yeah.
Now let's do cosine of theta. Cosine of theta is equal to x over r. So in this case, that would be 8 over 17, which will not simplify. It's already reduced to lowest terms. So there's our second answer. Then we do tangent. Tangent of theta is always equal to y divided by x. So in this case, that's 17 divided by,
15 divided by
15 divided by 8, thank you, which will not reduce either. 15 over 8. So there are your first 3. Those are your primary trig function ratios. We call those values. If I say find the value of sine, you can go and that's what I'll be asking for, is 15 over 17. You guys want to finish up the last 3? I think I could be wrong, but I think your book lists these in a weird order. I think instead of now going back and doing cosecant, I think, because they're going to list them as a string of numbers, so when you see the answers, the solutions manual, you know, I think next they do cotangent for some reason. And cotangent is x over y, which in this case is 8 over 15. You can also know that they're just reciprocals. So if I know tangent, I could just flip that one and I'll have the answer. Then they'll go to secant. And secant is defined as what? Does anybody remember? R over x, which in this case is 17 over 8, or just the reciprocal of cosine. And finally, we have cosecant of theta, and cosecant is defined as r over y, or the reciprocal of sine, which in this case is 17 over 15. Any questions? Now, they don't mean anything yet, but we are going to use them to solve triangles once we get out into chapter 2. Any questions? Nothing. You're completely comfortable.